For this next section, we're going to talk about complex numbers. And we've kind of touched on complex numbers just briefly in previous sections, and only in the fact that I've kind of alluded to them a little bit, or I've maybe mentioned that for some problems, like when we're dealing with square roots with negatives, I had said at the time we hadn't really talked about complex numbers yet. So we're going to do that today in this section. We're going to go over what a complex number is and how to work with them, how to just do basic operations like adding and subtracting, but then also get into multiplying, because going forward we're going to actually start solving problems, and you may have to deal with the complex number. You may have a negative square root, and in the future I want you to be able to handle that with the imaginary number, which is what we're going to talk about today. So your complex number is any time really that we have a negative square root. So there's a negative number underneath that radical sign. In the past, we really weren't able to solve it. So anytime that we came upon something that was like the square root of negative 64, we maybe really were kind of said we couldn't really do anything with that. But now that we're going to talk about the complex number, we'll talk about how to handle this. And eventually we'll talk more about solving quadratics. But where these come from, why we talk about this, is because if you think about a graph, and we think about a parabola, okay, so a quadratic equation, we've seen that so far already in this chapter. If I had the parent graph, parent graph looks like this for the quadratic function. It hits the x-axis one time at the origin, okay, and that would be the solution. But when we start to move the parent graph around, so let's say it gets shifted like this, well, now there's a spot where it hits the x-axis here and here. And so that would have two solutions that we should be able to find, whether we're factoring or using another method. We should be able to get those. But there are cases where, your parabola might look like this. Okay, and in that case, it doesn't cross the x-axis at all. So there aren't what we would call real solutions, but there are solutions to the quadratic here. It's just that they're going to be imaginary. And so that's where this piece that we're going to talk about today comes into place. So the imaginary number represents solutions out there that we wouldn't be able to actually operate with in the real number sense. When we see a negative underneath the square root sign, you're going to have the I come out if you were trying to simplify the answer. The other thing to keep in mind is if you have an I squared ever, that could be simplified to a -1. So if you think about this, if you had just I, that would be equal to just I. And if you have I squared, that would be equal to a -1. If you have I to the third power, that would be equal to a -I. And then if you go to I to the fourth, that would just be 1. And then you'd start to see this pattern start to show up again. And so it would kind of start to flip in between 1, -1, and a -I. So we're going to talk a little bit about how to work with the complex number here today, and how you actually can work as far as adding, subtracting, multiplying, and dividing with them, so that eventually in the future, when we start to solve things and these imaginary numbers come up, we know how to handle them. When you have a standard form of an imaginary number, it's going to look like this: a plus bi. The a represents the real portion of the number, and the bi represents the imaginary portion. So it could be something just like 5 plus I. That could be a standard form where 5 is your real number portion and I is the imaginary number portion. Or it could even be something like 5 plus 3I. 5 is still your real number piece, but the 3I then would be your imaginary piece as well. So what I want us to get into first is how we add and subtract. And when you're adding or subtracting complex numbers, think about what you would do when you had like terms. You would look for things that look similar and you would put them together. So when I look at these two, I would notice that there's a 5 and there's a 7. Those are both real numbers, so I should be able to combine them together. And then I see a negative 2i, and I see a plus 11i. So you can kind of hopefully see that I'm trying to highlight those in different colors because I want you to recognize that those would be your like terms. So if I add the 5 plus 7, that would give me 12. And then the negative 2i plus the 11i would become positive 9i. You add the numbers like you would normally, and then the I is just going to attach just like an X would. It's acting a little bit like a variable here, but it is representing something other than just like X would represent a number. I is representing that imaginary solution that we find. Now, when you have a subtraction one, I would just be aware of the signs and just be cautious of these ones. What I like to actually do first is rewrite this. So I'm going to bring down the 13i, and then I'm going to take this negative and I'm going to apply it to the 7 and to the 9i on the inside. So it's going to become minus 7 and then minus 9i. And the only reason why I do that is because sometimes if students don't, they will maybe think about subtracting the 7, but they will forget to take the negative and apply it to the 9i. And then when they try to combine their terms together, they get the wrong answer. So just something to be aware of. But so what I'm going to do now is I notice, again, I can highlight here that I've got 13i and the negative 9i. Those kind of go together. And then this negative 7 is kind of all by itself. When we write our answer, though, we always put the regular number, like the real number, part first. So negative 7 doesn't have anything to go with, so I'm just going to bring negative 7 down. And then I'm going to put the imaginary number second. And so I'm going to put 13i, but it's minus 9i. And so that becomes plus 4i. So watch your negatives on that one, and then make sure when you're writing it that you're always putting the real number piece first and then the I piece second. Okay, so that's adding and subtracting. If we flip our page over here, we're going to get into multiplying complex numbers. And kind of like with adding and subtracting, we almost treated it like they were just regular terms and we treated the I like a variable. We're going to do the same thing with multiplying. We're going to treat this like they were two polynomials or two binomials that we were multiplying together. And we're going to use the FOIL method in order to do this. So remember, FOIL stands for first, outside, inside, last, and those are just referring to the terms inside of your binomials that you're going to be multiplying together. And so it helps us kind of keep them in an order and allows us to just kind of keep track of what we've multiplied together. So my first terms would be 5 and 3, so multiplying those would become a 15. Outside terms would be the 5 and the 4i. So you're going to multiply 5 times 4, which would be 20. And then the I is just going to sit next to it. And then you're going to take the inside terms, which would be the negative 2i times the 3. So that becomes negative 6i. And then your last terms would be the negative 2i and the 4i. So negative 2 times the 4 becomes negative 8. And I times I becomes I squared. Remember we talked about earlier, though? I squared represents negative 1. So I'm just going to cross this I squared off, and I'm going to put negative 1 there. And so now what I'm going to do is try to simplify as much as I can here. So I can put these middle terms together because they're both just a number with an I attached. So I'm going to bring down my 15. I can put my 20i, and I can subtract my 6i, and that becomes 14i. And then when I take this negative 8 times a negative 1, that's just going to switch its sign. And so it's going to become plus 8. And so anytime you see an I squared, you can replace it with a negative 1. And then that's just going to change the sign of the number that's sitting in front. And then last thing I should be able to do is combine the 15 and the 8 because that I squared became a number. And so now it's no longer has the imaginary piece to it. And so 15 plus 8 would be 23. And then we still have the plus 14i because I couldn't do anything else with that. All right, next thing to talk about is dividing. When we're dividing complex numbers, think about when we had fractions that had like a square root inside of it, and we had to work with the conjugate in order to get the square root out of the denominator. We're going to have to do something similar here with imaginary numbers because we are not allowed to have imaginary numbers in the denominator of our fraction. So, in order to clear a denominator that has a complex number in it, we have to multiply by its conjugate. And remember, the conjugate just means that whatever your terms are and they're separated by a plus or a minus sign, the conjugate is the exact same thing, but you flip the sign in the middle. So, before we've seen something like 5 plus the square root of 3, and the conjugate would be 5 minus the square root of 3. Okay, all we did there is change the sign in the middle. We're going to do the exact same thing for these imaginary numbers. So we have 2 minus 3i as an example. The conjugate of that would be 2 plus 3i. When we multiplied by the conjugate with the square roots, maybe you remember that every time we did that, we ended up with an answer in the denominator that no longer had a square root. That's why we did it, because we didn't want to have a square root in the denominator. That was causing an issue. Now, when we're dealing with the imaginary number, the same thing is going to happen. When you multiply two binomials that have that imaginary number piece and you FOIL them together and they're conjugates, you're going to have, like, the first terms would be regular numbers that you're going to multiply by. The outside and inside terms are going to be the same two pieces put together, but opposite signs. And so they're going to cancel off. And then the last term, like we just saw when we multiplied, you're going to have that I squared pop up. And so you're going to be able to replace it with the -1, and then that's going to get rid of the imaginary number piece. So I'm showing you down here what this looks like with the example of the 2 minus 3i and the 2 plus 3i. I took 2 times 2 for my first terms because I'm foiling here, and that's how I got the 4. Then you'll notice my outside terms would be a 2 and a positive 3i, so that's where they got 6i from. And the inside terms are the exact same thing, except it's -3i times 2, and so that's -6i. So I'm hoping you guys will see, like, right here, those are going to cancel because they're opposite terms. And then your last is going to be that -3i times 3i, and that's where they get the -9i squared. And then they're showing you that they're replacing the I squared with the -1. Okay, so the middle terms are going to cancel, on all three of these lines, those are gone. And then you're going to see, okay, we're replacing this I squared with a -1. You take that times that -9, it becomes +9. And so you have 4 plus 9, and you get 13. That's what's going to happen in the bottom of these problems. I'm not guaranteeing that that's what's going to happen in the numerators. Sometimes in the numerators, you're going to have two different terms that you're multiplying together. It's okay if you have an imaginary number in the top of your fraction. It's not okay to have it in the bottom. But when we do this process, we shouldn't have one in the bottom anymore. So let's do an example here. We've got 4 plus 7i all over 2 plus 3i, okay? And we just talked about that denominator. We already know what the conjugate is. So I know I went through that process, but I'm going to do it again just so you guys can see it one more time. So I've got 4 plus 7i all over 2 plus a 3i. And the first thing I need to do is multiply by the conjugate. And we're going to do that on the top and on the bottom. So you're going to multiply by that 2 minus 3i on the numerator and on the denominator, okay? Let's just deal with the bottom right now for a second, and then we'll come back and do the top. So on the bottom, if we FOIL, first terms would be 2 times 2, which is a 4. Outside terms would be 2 minus 3i, multiplying them, so that becomes a -6i. The top is 3i, or I'm sorry, the inside terms are 3i and a 2, so that would be 6i. And last would be 3i times a -3i, which is a -9i squared. And that should look like exactly what we talked about up above, okay? I'm not throwing any curveballs there. Everything about that looks the same. Okay, and you're going to notice, like, right away, these middle terms should always be opposite, so I'm going to go ahead and just cross those out. We can replace I squared with -1, so I'm going to go ahead and cross this off and just write a little -1 here Okay, and then I'm just going to clean this up a little bit. So right underneath it here, I've got 4 plus the 9, and that's going to be a 13 on the bottom. Okay, so far that took care of everything on the bottom. I didn't do anything with the top yet, so let's go back to that and figure that out. So on the top, you can notice that they are not the same two quantities. They are different. So when we FOIL here, it's not going to just cancel off like we saw in the last one. Okay, so let's go ahead and FOIL those. So for your first terms, it'd be 4 times 2, which is 8. Outside terms would be 4 times that negative 3i, so that's going to be a negative 12i. Inside terms would be 7i times 2, so that's a 14i. And then last would be 7i times negative 3i, which is going to be a negative 21i squared. All right, so on the top, you've got this 8, and you can combine these I terms together. There's a negative 12i and a 14i, so together those would become 2i. And then what happens here with the negative 21? You should be able to replace that I squared with a negative 1. And so the negative 21 times the negative 1 is going to change that to positive 21. And then the last thing we should be able to do is put our real numbers together. So 8 plus that 21 is going to become 29. And I'm going to write that first. And then I have my plus 2i piece left over. The only other thing you would want to check is looking at these numbers like the 29, the 2, and the 13. If there was something that I could take out of all 3 of those numbers, I would want to. So if it was like a 28, a 2, and a 14, like if they were all even numbers, then I could take a 2 out of all of them, but I can't do that for this one. So I'm not going to be able to simplify it all. This is going to be my final answer. But that is something that I would just caution you on to make sure that you check and see if there's anything that you could possibly still take out to just reduce it a little bit more. Any questions on that? I would just keep in mind on anytime you see those kind of problems, the I should go away in the denominator. You're still probably going to have an I in the numerator, and that's okay. But it should be completely gone from the bottom. All right, if you go to the next page, we're going to just kind of work a little bit with the I that would come out of a square root that has the negative here. So anytime that we have the square root and there's a negative in there, that means that there's technically an I showing up. And I kind of touched on that at the beginning of the lesson here, but we're going to actually do some examples now where we practice taking out the I from our square root when there's a negative. So they're showing you kind of just in general, if I had any number that was underneath the square root sign and it was negative, I would take out the I, and that would just move to the front of my square root sign. And then the number that was underneath would become positive. So that I is just going to come out and take place of that negative that was underneath there. So for example, if I had like the square root of negative 63, sometimes what people will do is they'll actually physically write out the negative 1 to kind of represent that I term, and then they'll pull that out. But then if you also think back to a couple of units ago, I want to say it was like the second or the chapter P stuff that we were in, we did talk about breaking down square roots. And so you might have to do a little bit of that again. You might have to break down these radicals. So you can see what they did there is they looked for one of those perfect squares that went into 63. Remember, your perfect squares would be numbers like 4, 9, 16, 25, 36, and so on. So they saw that there was a 9. So they took that 9 and times 7. And then the square root of the 9, that comes out front as a 3. Okay. That negative 1 comes out front as an I. And then the 7 has to stay underneath the square root sign. Okay, so help me out with this next one. We've got the square root of negative 52. I'm going to go ahead and just pull out the negative 1 for the I, but what's a perfect square that can go into 52? I think the biggest one that we can do is 4, because I think 4 times 13 would be my 52. So what would come out of the square root sign? Think about what would be the square root of 4. That would become a 2. The negative 1 gets replaced with a I, and so that takes care of those. What happens with the 13? It's going to have to just stay, right? Because we can't square root 13 anymore, and so this would be my simplified answer. So it's really similar to what we did in chapter P when we were simplifying those radicals. It's just now you have to add on that I because there's that negative in there. And so that I is just representing the fact that there's a negative underneath the square root sign. So now if you look at the next one, we're trying to add these together. And remember when we had problems like this also back in chapter P, if you wanted to try to add square roots together, we had to have them be matching first, right? So I probably need to break these down. Okay, so what's a perfect square that goes into 27? 9, so 9 times 3. So think about that negative. That's going to come out as your I, but how would I simplify here? Because think these are both still underneath square root signs. So this would become 3. That square root of 9 becomes a 3. We have to put an I out now, and then this square root of 3 is just going to stay as is. Okay, now let's come over here to the 48. This could break down as 16, again, underneath the square root, times 3. Okay, so I'm going to bring down, we have a plus sign here. The square root of 16 becomes a 4, and I have to have an I because of this negative here. And then that square root of 3 just attaches. So now if you look, they both have the square root of 3, which means that you can operate with the numbers in the front. So if you think back to when we did this with just regular numbers, we had to break those square roots down first so that we could get the numbers underneath the radicals to be the same. So we're there. So now we should be able to combine 3i plus 4i. You're just going to add 3 plus 4, and that would be 7. And then I, square root of 3. So before you add or subtract square roots, make sure that they look the same underneath the radical. You can't just combine the 27 and the 48. It's not going to work out the same way. If you try to combine those and then break it down, you will not guarantee get the same answer. I mean, there's some cases where it maybe would work out, but it's not like a all the time thing. So you have to be really careful with that. Okay, last one I have here is kind of getting back into multiplication a little bit, but if you look at this, there's a lot of negative signs in this one, okay? There's -2 minus the square root of -3, and it's all squared. This is not the same case as the conjugate because this is the same quantity 2 times, so they're both going to have minus signs. So I would actually maybe suggest that we write this out first. So I'm going to write -2 minus the square root of -3, and then times the exact same thing. I'm going to try to simplify this even a little bit more. I see that negative underneath the square root sign. I'm just going to take that out right now and work with it as an I. So down here, I'm not going to really change much, except I'm going to write -2 minus and then an I square root of 3. And then the same thing over here for the second one. Okay, now I'm going to begin my foiling process. So first terms would be -2, -2 times each other. So that becomes +4. Outside terms would be -2 times this -I square root of 3. There's not a lot that I can combine there, but I can put some things together. I also have a negative times a negative, so it is going to become plus, and then I'm just going to write 2i square root of 3. My outside terms are my inside terms are the exact same pieces, a -I square root of 3 and a -2. So I'm going to have another +2i square root of 3. And then my last terms would be this -I radical 3 times -I radical 3. So a -I times a -I becomes positive I squared. And square root of 3 times square root of 3, they're both underneath the square root sign, so we can multiply those and get a square root of 9. Okay, hopefully you were able to kind of follow me there with my foiling. I tried to kind of underline and draw things to kind of keep track of what we did there. So now I'm going to kind of just zoom in on this. I'm going to be able to put these two terms together, okay, because they're matching. I really can't do anything with that 4 right now. Over here, the last term, let's talk about what happens. What is the square root of 9? A 3. So I'm going to write that above it. This becomes a 3. That takes care of the square root of 9. What is an I squared? It's a -1. So I'm just going to write that there next to it. Okay. So now if I think about what's going on, I have this 4. And then if I combine these middle terms because they're the same, it's just going to be 4I square root of 3. And then last here I have this 3 times a -1, which would be -3. What is the last thing that you could put together? You can put the 4 minus 3 together. That would just become 1, and then plus 4I square root of 3. And that's your answer. So I'm going to zoom out there, kind of big picture of everything. Do you guys have questions on that problem?